So let's look at this equation here. We have x squared plus 6x plus 5 is equal to 0. And so far we've learned 5 ways to solve this equation. So the first way is we've learned graphing. So there's your table of values. You can plot these points on your graph here. So we would have -5, 0, -4, -3, -3, -4, -2, -3, and then -1, 0. So if you sketch your graph, that's what it would look like. And your solutions would be -5 and -1. If we factored this, I need two numbers that will multiply to 5 but add to 6. And so that would be 5 and 1. So if I factor it, then I set each factor equal to 0 and then solve. So x equals -5 and x equals -1. So next is square root. So we can't actually solve this using a square root because we have a bx term. We have that middle term there. So cannot be used because there is a bx term. So square roots are only used whenever you have the x squared and then the number. We can use completing the square. This one works with any function. So if we move the 5 to the other side, we would get x squared plus 6x is equal to -5. So then we take the 6 and divide it in half, and that gives us 3. And then we square that and gives us 9. So then x squared plus 6x plus that 9, I'm going to add that to both sides. Okay, and so whenever I factor this, I will get x plus 3 squared is equal to 4. Take the square root of both sides. You will get x plus 3 is equal to plus or minus 2. And so you have two options. One where you have, so if I subtract 3 over there, -3 plus 2 or -3 minus 2. So -3 plus 2 is -1, -3 minus 2 is -5. So next is a quadratic formula. So we can say our a is 1, b is 6, and c is 5. We can plug it into our quadratic formula, so -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You can simplify this. You will get the square root of 16 over 2. And so this will, the square root of 16 is actually 4. So we'll have -6 plus or minus 4 over 2. This gives us two answers, -6 plus 4 over 2 and -6 minus 4 over 2. So -6 plus 4 is -2 over 2, which is -1. -6 minus 4 is -10 over 2, which is -5. So no matter which way you do it, you get the same answer. The only thing you can't use is the square root option. So let's talk about all of the methods and when we can use them. So graphing can be used sometimes, and we can use it whenever our roots are integers. And an integer is a positive or negative whole number. Okay. Now we have factoring. So factoring can be used sometimes whenever it's factorable, and you'll know that by the roots are rational, which means that if you were to use like a square root or the quadratic formula, then that number underneath the square root is a perfect square. Okay, so a rational number is a positive and negative whole number and a fraction. Okay, we can use square roots sometimes whenever there is no bx term. There's no x to the first. Completing the square, we can use always. It's best to use it when there is no x squared coefficient and an even bx term. So there's an even b. And then the quadratic formula, we can use it always. You can use it whenever other methods are insufficient. So this works anytime. There's no stipulation for this. So let's talk about this discriminant. So the discriminant, it gives the number of roots and the type. So our discriminant is that formula underneath the radical in our quadratic formula. So it's b squared minus 4ac. That's how you find your discriminant. If your discriminant is positive and it's a perfect square, you will have two roots and they will be real and rational, which means there's no square roots left over. Okay, so if it's a perfect square, there's no square roots. This is a good option for factoring. Okay, so if your discriminant is positive and it's a perfect square, I would use factoring. If it's positive and it's not a perfect square, you still have two roots, and they will be real and irrational, which means that you will have a leftover square root. Okay, and in this case, I would use either the quadratic formula or completing the square. If d is equal to 0, that means you only have one root, and it's real and rational, which means no square roots. And then if your discriminant is negative, you have two roots, but they are imaginary. And so that might be a case for the quadratic formula. So I have 4 equations here, and I'm going to figure out which method to use just by the discriminant. So you find the discriminant, and then that'll tell you kind of which method you can use. So first things first, on A here, we need to identify A, B, and C. So A is 1, B is -9, and C is 21. My discriminant is going to be b squared minus 4ac. So if you simplify that all down, you will get -3. So my discriminant is negative, which means you will have two imaginary roots. Okay, so we'll hang on to that for just a second. So 2 imaginary. Okay, and so B, our discriminant, so A is equal to -2, B is equal to 0, and C is equal to 144. So B squared minus 4 times A times C. So that will give you 1152. And that is not a perfect square. Okay, so you will have two real irrational roots. Okay, which means that you will have a square root left over. Let's look at C. So A is 3, B is -22, and C is 7. So B squared minus 4 times A times C. Okay, so that will simplify to 400. That is a perfect square. It's a perfect square of 20. So we will have two real rational roots. That might be a good one for factoring. And then looking at equation D here, so A is 1, B is 6, and C is negative 15. So we have B squared minus 4 times A times C. This will simplify to 96. So we will have 2 real irrational roots because 96 is not a perfect square. Okay, so now that we know this, we know what the discriminants are and we know what kind of roots we're going to have, let's match each method to the equation that would work. So right away I look at B. There is no bx term. So that is a perfect match for solving by a square root. Then I look at the imaginary, so A. If I have 2 imaginary roots, that might be a good match for the quadratic formula. So now I have C and D. I have 2 rational roots and 2 irrational roots. Since I want the rational roots, the real numbers, to go with factoring, we'll say that we'll use factoring to solve C. And then the irrational roots, we'll say that we will use completing the square. Now, in reality, you can choose any method, and if it doesn't work, you might just have to try another one. Okay, so, but this does help save some time a little bit and kind of have some forward thinking as to how you're going to solve some of these equations. But from here on out, you can use any method you want.